So, good day, welcome back. Now we are coming again to another beauty of chapter, and that is about AC, alternating currents. Okay, the alternating currents are generated by the very simple of Faraday-Henry Lenz law. The AC generator, in which the mechanical energy is converted into an electrical energy. Okay. So dynes are converted into mhos, amperes, and therefore there is an old name, and that is dynamo. But dynes is the unit of force in the CGS system, and amperes of course have been the unit of current, and the current has been considered to be one of the leading factors. So this chapter we call alternating currents, and let us look into what is the basic theory about the AC generator. We know that the flux through a coil due to a magnetic field is given as B dot A, which is the flux is a scalar. It turns out to be equal to BA cos of theta, because we learned that in the vector analysis. And if that theta is related to T by a simple proportionality, direct proportionality, then theta turns out to be equal to omega T. And what evolves over here is a difference circle which I have talked to you about in the simple harmonic motions case and other cases also. So this theta is equal to omega T. A linear relation between theta and T exists, and the slope is, this is the kind of relation that we'll have between theta and T, and the slope is equal to omega. Okay. Now, thanks to the studies of young Michael Faraday and Professor Henry at Princeton, and later on Lenz in the Germany at that time, we found that the developed electromotive force E is equal to minus d phi B O dt, which in our case, I must tell you one thing before I go explain this, that here we have B and A. We can change B, we can change A, and we can also change, we have preferred to make a change in the value of theta by this relation which we have. So anyway, this will turn out to be equal to minus BA ddt of cos of omega t, because B and A as a scalar and B also is a scalar here, so ddt of cos of omega t. And by the process that I told you, which I will stick to because you have become quite versed in that, this is equal to BA into ddt of cos of omega t, which will turn out to be equal to cos of omega t plus pi by 2 into ddt of omega t. and which turns out to be equal to omega. Well, what we have obtained is my simple submission to you that cos of omega t will become cos of omega t plus pi by 2. That is the phase enhances by pi by 2 radians. Now this cos of theta plus pi by 2 is equal to minus sine of theta. I told you this before also. So, because the minus sign is there, so what I will write? I'll write this BA omega sine of omega t. Okay. This is for a single turn of this coil which is there in the magnetic field of a magnet, north this and south this, and that I have not shown. You can look into the books for the correct drawings made by professional draftsmen. Okay, so for n turns, all I will do is that I will multiply this by n. So NBA omega sine of omega t, which I can write as Em. Some books they write it E naught. Doesn't matter. Symbols don't matter at all, as long as the meaning is the same. Em NBA omega. Okay. So I can write this as Em sine of 2 pi nu t also, because omega is equal to 2 pi nu. Right? And then I can plot this expression E is equal to Em sine of omega t or sine of 2 pi nu t as shown over here in the red diagram. This turns out to be equal to, for t is equal to 0 or omega t is equal to 0, the value is 0, thereafter it increases, reaches a maximum value, and then it goes like this. Okay. Where the points over here and here and here and here, etc., they are marked in terms of t as t by 4. The capital T is time period equal to 1 upon nu, 2t by 4, 3t by 4, 4t by 4. I don't write this as t by 2, I don't write this as t. And the corresponding values, once we have this omega t, then pi by 2, 2 into pi by 2, 3 into pi by 2, 4 into pi by 2, and you can see the period, it repeats itself after this much of time and this much of angle that has traversed. Okay, so this is it. We can find out as to what is the average value. Yes, let me define AC right now. Okay, one of the definitions of AC is that for an entire period, which we can take from here to here, here to here, here to here, here to here. Okay, the average value is equal to 0, because the area of this is equal to the area of this. To find out the average value, we have to find out this area under the curve for a 0 to capital T or T to 2 capital T or nt to n plus 1 capital T, and we find that the net area is equal to 0 divided by the time which has taken place, which is equal to capital T, and this will turn out 0. So anyway, there will be occasion to talk about that. Okay, now the introduction of alternating currents, it actually starts from here, where we write that AC, alternating currents. And then, funny thing, AC voltage, how do we read it? Alternating current voltage. No, we'll just read it as AC voltage. AC current, alternating current looks funny, but we'll rather say that this is AC current. So we'll live with that, with history, with our forefathers who maybe committed mistake, or maybe they were very okay. Now the first item that is normally put is AC voltage applied to a resistor. Who is Mr. Resistor? I told you before that Mr. Resistor is an energy consuming device, is the Raja Beta of the electrical system. Whatever give to him, there will be an I square R joule loss associated with our friend Mr. Resistor. So there is a dissipation of energy. Whatever you give to in the form of energy or power, that is dissipated. Okay. So I don't care. I don't want anything. Whatever you are going to give to me, I am going to spend it. Okay. Okay. So we make a circuit where I have an AC generator, or I'll rather call it an AC source of EMF. There is a tilde here. This Mr. Tilde shows that it varies with time. The value of the voltage over here. I am not taking the thing E, but instead what we talk about is the voltage. What is Mr. Voltage? Mr. Voltage is a potential difference. Okay. Of course, Miss Current is the current. So, like this, if I apply here, then the current flows out of the positive terminal whenever it is positive, and it will go like this. Because this alternates, though when this becomes positive and this becomes negative, the current goes like this. Okay. So in this particular case, we understand that at this moment of time we are talking about the voltage is plus and minus. And then there is our friend Kirchhoff and Kirchhoff's voltage law. Okay. And that says that in a loop, in any loop, the net fall of voltage or the net rise of voltage as you go from one point round the circuit back to the same point, that will be equal to 0. So when I apply this plus, this minus, this plus, this minus, so I write this V as equal to Vm sin of omega t in keeping with this. So this turns out to be equal to, applying the KVL, I'll write V is equal to Ri. This is Professor Ohm's law, the school teacher from Germany. We studied this and made a great name. So KVL, Ohm's law, and then I apply the value of I turns out to be equal to V upon R. V is equal to Vm sin of omega t divided by R. This gives Vm upon R sin of omega t is equal to, I will write this as the maximum current into sin of omega t. Im is equal to Vm upon R. Okay. There is much more than meets the eye if we stop here. So we continue. So we had this AC voltage applied to a resistor. We found that Im is equal to Vm upon R. And now let us take up the instantaneous power dissipation in the resistor, which we have defined earlier as I square R, V square upon R, and I into V. Okay. Well, this is the formulae. These are the formulae for the power dissipation in the Raja Beta. So P is equal to I square R is the instantaneous power dissipation. Okay. And I can write it as, therefore I is equal to Im sin of omega t. So Im square sin square of omega t into 1. And you know that we have done this kind of mathematics. Cos of 2 theta is equal to cos square theta minus sin square theta, and there is the famous relationship cos square theta plus sin square theta is equal to 1. Therefore cos 2 theta becomes equal to 1 minus 2 sin square theta. Also it can be written as 2 cos square theta minus 1. So sine square theta becomes equal to 1 minus cos 2 theta divided by 2, and cos square theta becomes 1 plus cos 2 theta divided by 2. Now this kind of mathematics I have done before, and taking advantage of that, I can write here Im square r is equal to, for sine square of theta, I can write 1 minus cos 2 theta upon 2. Okay. So the frequency doubles and the time period becomes half for this function, which splitting I can write as equal to Im square r upon 2 minus Im square r upon 2 into cos of 2 omega t. Okay. Of course, when I do this Im square, so I have shown here as to how the voltage in the blue pencil and the corresponding current in the red pencil, they vary. They have one-to-one correspondence. There is no time lag or time lead, etc. So in the case of resistor, we can say that they go hand in hand, okay, shoulder and shoulder, together and together, and the voltage and the current, they enjoy whatever. Now let us try to see as to what will be the average value of the instantaneous power, which I write as this, over a cycle. Then, now the thing is that this function cos of 2 omega t, if we integrate it over a time period, then this will turn out to be equal to 0. Cos of omega t, cos of 2 omega t, cos of 3 omega t, cos of n omega t, where n is an integer, that average value turns out to be equal to 0, because I defined to you the sinusoid is the one in which the average value vanishes. Doesn't matter what is the frequency, etc., etc. So now if I plot on the same graph Im square, for example, so I'll get something like this, and for this cycle, this half cycle, also I'll get something like this. Okay. And we have to take the average value of this thing, which is positive here and positive here, for this half cycle, positive half cycle and the negative half cycle, both of them it is like that. No problem. So how come? This is how we obtain this. But once upon a time, when I was a young man, a certain student did not subscribe to this. I don't know mathematics and I hate mathematics, this and that, that and this. Then I had to come out with an indigenous idea. And I said, well, young lady, tell me, what is the average value of sine square of theta plus cos square theta? And she said, because value is always 1, therefore the average value or whatever value for sine square theta plus cos square theta will be equal to 1. So, okay. Let's plot a sine graph and let's plot a cosine graph. It will start 0, it will start here, and the cosine graph will go like this. She said, okay. I said, okay. Tell me, if I square these things and I take the average value for a long period of time, then do you subscribe to this? That sine square of theta, average value will be equal to cos square theta? She said, yes, they should be equal. I said, okay, problem is solved. So when this value is 1, then this value got to be half, and this value also got to be half. And she was very happy. I hope you are also going to be happy about it. Okay. Now the next item is to define you the value of I, which is also called I effective. Now effective how much effective it is. Okay. Then you will know, friends, that if there is DC and the DC value is I, and our Mr. Resistor, the Raja Beta, okay, Raja means the king, okay, the prince, okay, prince of Tartary, knows only how to dissipate in the form of Joule heating. Then the average value will be equal to I square R. And here I am getting, look here, here I am getting the power value as Im square R upon 2. Okay. So this, I can therefore say that the two can be equated. I and this is equivalent to Im square upon 2. Okay. The average value here it will be I because this is DC and this is equal to like this. So what happens? What happens? This is the maximum value. Im I have shown over here. Minus Im I have shown over here. This is the maximum value. So I is equal to IRMS. I'll tell you why it is RMS. Okay, because RMS stands for root mean square. But it is done in the reverse process. First of all, we take the square, then we take the mean, and then we take the root. So this I have defined to you in the case of RMS velocity while dealing with the kinetic theory of gases. So therefore we can say that this value I is equal to like this. Okay, I is equal to like this. We make the square, we take the mean, and we then take the root. So square mean root, but instead we say root mean square historically. Okay, and RMS also is more musical as compared to if I say SMR. Okay, SMR. One of my cousins who is a very good mathematics scholar, his books are very much available. SM Rizvi. Okay, so but I like RMS. People liked RMS, and so it became RMS. So RMS is the effective value of the current, which can be said to be equal to Im by root 2, and 1 upon root 2 is equal to how much? 1 upon root 2. Remember, this is equal to root 2 by 2. Multiply numerator and denominator both by that. And root 2 is a beautiful value, 1.414. And this divided by 2 gives another beautiful value, 0.707. The first Boeing aircraft which did fly over our hostel, okay, and that night we were just looking for it because the information was there that the Boeing will go, and it was making a lot of noise at that time. So we were waiting for it. Some of us were sleeping there on the dining hall Atari. Okay, and so this value is 0.707, and there was another thing 707 love from Russia. So that thing, I am not going to the details of it. So VRMS will become equal to how much? Vm upon root 2. IRMS will become equal to Im upon root 2. And if you care, to write it as capital IM, I don't mind. Capital VM, I don't mind. Maybe later on I can write to you. So this is about one thing I would like to tell you, that V is equal to Vm sin of omega t. This we take when we have the, what do we call it? This is the center and there is a vector, and this is the initial position, okay, of this vector. Then this vector is made to rotate like this with an angular velocity omega, okay, and here we have the value of theta. But sometimes what we can do is we can initiate from here, and this I can write as, say, delta, and this becomes equal to theta equal to omega t. So I can write this expression also as V is equal to Vm sin of omega t plus delta. And what do I call this angle? This is the angle, but we also call it argument of sine. This is one way in mathematics we call it, but in physics we often call it as the phase. And at the time t is equal to 0, you can see that the total phase is equal to delta. So this delta becomes the initial phase, and we can write all those equations with the help of omega t plus delta. No problem, the same results will be obtained. So I have enjoyed, and I hope I rather tell you to take a couple of leaves of paper, write these things all by yourself, okay, once you have done it, and then enjoy is the result, final result. If you enjoy, I am successful. If you don't, I don't. Thank you.